Ever wonder how a rail engine, a magnificent masterpiece of human engineering, roars to life and transports us across landscapes? It's an experience, isn't it? The rhythmic chugging, the billowing steam, the thrill of speed, all orchestrated by a marvel we often take for granted. The rail engine, often referred to as the Iron Horse, is a fascinating combination of art and science. It's a testament to our desire to conquer distances, to reach the unreachable. It's not just a vessel of transport, but a symbol of human ingenuity. Understanding how this iron beast works is like peeling back the layers of a complex mystery novel, each page revealing a new twist and turn. This mechanical marvel operates on principles that are both simple and complex. Simple because, at its core, it's about converting energy from one form to another. Complex because the process involves a series of intricately connected components, each playing a vital role in propelling the engine forward. Now you might ask, why is it important to understand the workings of a rail engine? Well, it's not just about quenching our curiosity. It's about appreciating the genius behind the design, the precision in the assembly, and the hard work that goes into maintaining these machines. It's about acknowledging the role of rail engines in shaping our history, our economies, and our societies. Moreover, it's about marveling at the intricate dance of physics and engineering. The rail engine is a living demonstration of the laws of thermodynamics and mechanics, a tangible manifestation of scientific principles we often learn in the abstract. So, are you ready to delve into the heart of this Iron Horse? To understand the complex system of components that come together to make the rail engine work? To appreciate the symphony of pistons, wheels, and valves that orchestrate the journey of a train? Join us as we unravel the magic of mechanical engineering that propels a rail engine. At the heart of a rail engine, there lies a steam machine. Let's take a moment to appreciate the marvel of engineering that is the steam machine. In essence, it's a giant kettle, but a kettle with a profound purpose. It's here where a transformation takes place, where water becomes steam and steam becomes power. The process begins with the boiler. This is a large cylindrical vessel filled with water. A fire is lit beneath it, in the firebox. The heat from the fire turns the water in the boiler into steam. But this isn't your everyday steam. This steam is under pressure, and it's this pressure that gives the steam its power. Heat and pressure work together in a delicate dance, creating a force that's ready to be harnessed. But how does this force make a rail engine move? The answer lies in the pistons. The pistons are cylindrical components that move back and forth inside a cylinder. This is where the steam comes into play. The high-pressure steam from the boiler is fed into the cylinder. As it enters, it pushes the piston one way and then the other. This back-and-forth movement is known as reciprocating motion. Now, this reciprocating motion on its own wouldn't be much use for moving a rail engine. It needs to be turned into rotational motion, and that's where the connecting rod and the wheels come into play. But we'll get to that in the next scene. The beauty of the steam machine is in its simplicity. It's a process as old as the Industrial Revolution itself, yet it powered the rail engines that transformed our world. It's a testament to the ingenuity of the human mind and a reminder of the power that can be harnessed from the most basic of elements. Remember, it's not just steam that's being created in that boiler. It's power, it's motion, it's the lifeblood of the rail engine. This steam power is what sets the rail engine in motion. So, we have steam power, but how does it get transferred to the wheels? Let's take a deep dive into the heart of the locomotive, where the magic of motion begins. Our main players here are the pistons, connecting rods, and wheels. A piston, in its simplest form, is a movable plug that fits tightly inside the bore of a cylinder. Its primary role is to convert the energy created by the steam's pressure into mechanical force. When the high-pressure steam enters the cylinder, it pushes the piston, causing it to move back and forth inside the cylinder. This back-and-forth motion is what we call reciprocating motion. However, we need the wheels to rotate, not reciprocate. So how do we get from a back-and-forth motion to a round-and-round motion? This is where the connecting rods come into play. Connecting rods are the unsung heroes of the locomotive world. They act as intermediaries, connecting the piston to the driving wheels. As the name suggests, they connect the linear motion of the pistons to the rotational motion of the wheels. Imagine a child on a swing. The swing moves back and forth just like our piston. Now imagine if we tie a rod to the swing and connect the other end to a wheel at the playground. As the child swings back and forth, the rod will push and pull, causing the wheel to rotate. That's exactly what happens inside our locomotive. The connecting rod attaches to the piston at one end and to the driving wheel at the other. As the piston moves back and forth, the connecting rod pushes and pulls, turning the wheel in a circular motion. And so, by a series of pushes and pulls, the steam's energy is transferred from the pistons through the connecting rods and into the wheels. This is the secret behind how a locomotive moves. It's a dance of mechanics, a symphony of motion. And voila, the wheels start turning. But how do we control this power? Enter the valves. Now let's imagine the steam as a wild horse, strong and powerful. However, without a rider to guide it, this horse could just run aimlessly, maybe even cause chaos. The valves are the rider of our metaphorical horse, guiding and controlling the steam's power to ensure everything runs smoothly. Valves play a pivotal role in controlling the flow of steam into the cylinders. They're like the gatekeepers, deciding when to let the steam in and when to keep it out. They're crucial in starting, stopping, and even reversing the engine. Picture a seesaw. On one side, we have the steam pressure, and on the other, the piston. When the valve opens, the steam rushes into the cylinder, pushing the piston with its force, just like a child jumping onto a seesaw. When the valve closes, the steam is trapped and the piston slides back, ready for the next push. This back and forth motion is what drives the wheels of the engine and ultimately propels the train forward. But that's not all. The valves also control the speed of the engine. By adjusting the valve timing, we can regulate how much steam enters the cylinder and how quickly it does so. The more steam we let in, and the faster we let it in, the quicker the piston moves and the faster the engine runs. It's like adjusting the throttle on a car. However, the valves aren't just on or off switches. They need to be finely tuned to match the needs of the engine. Too much steam too quickly, and the engine could overheat. Too little, and the train might not move at all. So, while the valves might be small components in the grand scheme of a rail engine, their role is anything but minor. They're the directors of the steam, the conductors of the piston symphony. The valves, small but mighty, hold the reins of the rail engine's power. So, we've traveled through the intricate world of a rail engine, but how do all these parts work in harmony? Well, the symphony of a rail engine is a marvel of engineering, where every component plays its part with precision and grace. The heart of the rail engine, the steam machine, is where it all begins. Here, water is heated to create steam, the raw power that sets the wheels in motion. The boiler, the furnace, the firebox, they all come together to create this vital force that drives the engine. Next, we have the pistons and cylinders, the rhythm section of our orchestra. The steam from the boiler drives the pistons back and forth in the cylinders. This motion is then converted into rotational motion, which drives the wheels. Each piston and cylinder, working in perfect synchronization, propels the engine forward, contributing to the rhythm of this beautiful symphony. Then the valves, the conductors of this symphony. They control the flow of steam into the cylinders, ensuring the right amount of steam enters at the right time. The valves open and close with clockwork precision, guiding the steam to the cylinders and ensuring the engine runs smoothly. The wheels and axles, meanwhile, are the dancers of this symphony, gracefully carrying the weight of the engine. They take the rotational motion from the pistons and cylinders and translate it into the forward movement that we see. Their dance is a testament to the harmony and balance of this symphony. And finally, the rails, the stage on which this symphony is performed. They guide the engine, ensuring it reaches its destination safely and efficiently. Each of these components, each of these musicians, plays its part in this grand symphony. They come together, each contributing their unique sound to create a symphony that is as beautiful as it is complex. And that, my friends, is the symphony of a rail engine, a testament to human ingenuity. It continues to captivate and transport us.